Welcome. Let your shoulders sink into whatever is holding you right now, and let your breathing find its own slow rhythm. Nothing here needs your attention, only your rest. Tonight we follow the long, looping journey of a sea turtle, from a warm hollow of sand to open water and back again. A turtle's story begins beneath the sand, not the sea, buried in darkness before it ever meets the waves. Temperature inside the nest quietly decides whether a hatchling will be male or female. No claws, no genes alone make that choice, warmth does. A few degrees one way or another, held steady for weeks, tips the balance entirely. Cooler sand tends to favor males, warmer sand favors females, and the middle ground holds both. It is one of the few places in nature where climate itself writes an animal's sex. Loggerhead eggs incubate for about 2 months in warm sand before anything stirs. Beneath the surface, each egg rests in stillness, drawing heat from the beach around it. The mother is long gone by now. Her part finished the night she dug the chamber. Inside each shell, a tiny form takes shape slowly, curled and waiting. 2 months of sand, sun, and silence prepare it for a single brief dash to water. The beach itself breathes, exchanging air through countless grains of sand. Oxygen filters down to the buried eggs, and carbon dioxide rises back toward the surface, drifting out between grains too small to notice. This slow exchange keeps the developing hatchlings alive without a single motion from outside. Rain, tide, and wind all shift how easily that air moves through the sand. A beach, in its own quiet way, keeps every nest supplied. Hatchlings synchronize their emergence inside the nest chamber, though no one taught them to. Each turtle stirs at roughly the same time as its siblings, cracking free within the same narrow window. Movement from one hatchling seems to trigger movement in the others nearby. This shared timing turns dozens of separate efforts into a single coordinated push upward. By instinct alone, a whole clutch learns to rise together. A rise in nest temperature near dawn triggers the final climb toward the surface. As sunlight warms the sand above, the chamber below grows slightly warmer too, and that shift seems to signal the moment has come. Hatchlings that had been resting begin to stir in earnest. Their small flippers press upward against loose sand, inch by inch. Warmth, in this last stretch, becomes the quiet cue that says it is time. Digging out of the nest takes the whole clutch working together, not any single hatchling alone. Each turtle scrapes at the sand above it, and the grains fall downward, filling the space beneath the group. Slowly, the whole cluster rises as one, carried upward on sand it has just displaced. No hatchling could climb out alone. The chamber would simply cave in around it. Together, they build their own staircase out of falling sand. Emergence usually happens at night, when sand is cooler and predators are fewer. Daytime heat can be lethal to a hatchling's small body, so the clutch tends to wait beneath the surface until dark settles in. Cooler grains near the top signal that the sun has gone. Under starlight, the sand finally gives way. What began as a shared struggle underground ends in open night air. Hundreds of hatchlings can erupt from a single nest at once, spilling across the sand in a sudden wave of motion. What was hidden for 2 months appears all at once, small dark shapes moving in every direction. The beach, empty moments before, briefly fills with life. It rarely lasts long, this burst of movement. Within minutes, the sand will look undisturbed again, as if nothing had happened there at all. Reaching the sea takes only minutes, but decides everything that follows. Every hatchling scrambles downhill, guided by instincts it has never had the chance to test before. Ghost crabs and shorebirds may be waiting nearby, unseen in the dark. Speed matters here more than direction, though direction matters too. Those minutes on open sand are, for many, the most dangerous stretch of the entire journey ahead. Let your breath settle into its own slow rhythm now, no counting required. Feel the inhale rise and settle, then let the exhale stretch a little longer than before. Each breath out can carry a little more weight from your shoulders. There is no place you need to be but here, wrapped in this dim and steady quiet. Let the next breath simply happen, gentle as tide. Far beyond the dunes, hatchlings look toward the brightest, lowest edge of the sky. Open water reflects starlight and moonlight in a way that dry land rarely can. Dune grass and shadowed hills stay dark by comparison, offering little glow to follow. A hatchling's small eyes read this contrast instinctively, without hesitation. The horizon itself becomes a kind of invitation toward the sea. Waves offer a second kind of compass once hatchlings reach the surf line. Incoming swells press steadily toward shore, and swimming against that push means swimming toward open water. A hatchling feels this rhythm through its whole small body, adjusting stroke by stroke. Even in darkness, even without sight of land or stars, the pattern of water tells a clear enough story. Direction here is something felt more than seen. For 2 or 3 days, a hatchling paddles almost without pause, a stretch of effort called the frenzy swim. This burst carries it well beyond the shallow, dangerous water near shore. Rest barely enters into it during these early hours. Momentum matters more than comfort now, and the small flippers keep working long after they might otherwise tire. Distance from the coast becomes its own quiet form of safety. Small lungs and a shrinking yolk reserve fuel this frantic opening chapter. The yolk, absorbed just before hatching, holds enough energy to power days of steady paddling without feeding. Each breath at the surface is brief, just enough air to keep moving. Nothing here is wasted. Every ounce of stored energy goes directly into distance, carrying the hatchling further from the shore that once held it. Not every hatchling that reaches sand will reach water. Ghost crabs wait near their burrows, alert to any motion nearby. Gulls and herons circle low, watching for the scramble to begin. The open beach, calm and empty most nights, becomes a brief stretch of risk the moment hatchlings appear. Speed offers the only real defense during these unguarded minutes above the tide line. Herons, crabs, and wading fish turn the short walk to water into a narrow passage. Above the sand, birds strike quickly and without warning. At the water's edge, crabs seize what they can reach. Just past the shallows, small fish gather where the surf meets deeper water, ready for what drifts within reach. Each hazard claims its share before the hatchlings ever clear the breakers. Deeper water, oddly enough, offers more safety than the shallows ever could. Predators along the shoreline are concentrated and watching, while the open sea spreads danger thin across a much wider space. A hatchling lost among countless waves is harder to find than one crossing a narrow strip of sand. Distance dilutes risk in a way that proximity to land never allows. Something changes completely once a hatchling clears the breakers. The frantic, all-out paddling begins to ease into a steadier, more measured rhythm. Ocean currents start doing more of the work than muscle alone. What was urgent survival becomes something closer to travel. The sea, once just an escape, now becomes the space where the rest of its life will slowly unfold. Decades ago, a naturalist named Archie Carr spent years wondering where hatchlings disappeared to after the frenzy swim. He had watched thousands leave the shore, yet almost none turned up again until they were nearly grown. No nets, boats, or beach surveys ever caught them in between. Carr kept returning to the same unanswered stretch of a turtle's early life, certain the ocean was holding onto an answer he could not yet see. Marine biology eventually settled on a name for that missing stretch of a turtle's life: the lost years. The term marked the span between a hatchling vanishing past the breakers and its reappearance, much larger near coastal waters. No tag, boat, or survey had managed to bridge the distance. The label stuck simply because nothing more precise existed yet. For decades, that phrase held open a question the ocean had not yet answered. Let your body grow heavy now, one part at a time. Feel your heels sink first, pressed into the mattress like stones settling into sand. Let that heaviness rise into your calves, then your knees, resting there without any effort of your own. Your arms follow, then your shoulders, given fully to what holds them. Even your jaw can loosen, released from a day it no longer needs to carry. There is only this weight and the surface beneath it. Sargassum mats drift across the ocean's surface, tangled rafts of golden brown algae stretching for meters at a time. These floating islands offer both shelter and a meal, hiding hatchlings within their branching fronds. Small fish and shrimp gather among the same tangles, drawn by the same cover. For a tiny turtle, the mat forms a floating world, small enough to hide inside, wide enough to disappear across. A young turtle may spend a year or longer tucked within these floating mats, carried wherever the current leads. Growth happens quietly out of sight, far from any shoreline or passing boat. Tangled branches break up the sunlight overhead, casting a dappled cover across the water. Few predators bother searching such scattered, drifting shelter. Time passes there almost unmeasured, marked only by the turtle's own gradual lengthening shell. Warmth in these surface waters suits a hatchling's small developing body well. Cold saps energy a young turtle cannot yet afford to lose. Staying near the sun-warmed top layer keeps its metabolism running at a pace it can sustain. Deeper water, only meters below, can run noticeably cooler. For now, the surface remains the safer place to keep growing. Crabs, snails, and drifting insects offer a hatchling's first true meals at sea. Many of these small creatures cling to the same sargassum that shelters the turtle itself. A young turtle picks through the tangled fronds, taking whatever small body drifts within reach. Nothing here is hunted far or fast. The meal simply arrives, carried by the same current that carries the turtle. The open Atlantic gyre carries loggerhead hatchlings on a broad, circular tour of the basin. Currents loop clockwise across the entire ocean, forming a ring wide enough to take years to complete. A hatchling caught within it may drift from Florida past the Azores, then back toward warmer waters near the Caribbean. The path is a wide circle, never a straight line. Somewhere within that loop, a turtle grows older, always moving, never quite lost. Currents, not muscle, carry a young turtle through most of these early years. Paddling matters less than positioning, letting the moving water do the harder work. A hatchling conserves strength this way, saving energy for growth rather than distance covered. The ocean supplies the motion, and the turtle simply rides within it. Pacific loggerhead hatchlings, born on the beaches of Japan, enter a very different current system entirely. The Kuroshio carries them northeast across the open Pacific, a warm river running through a colder sea. Some eventually reach waters off Baja California, an ocean away from where they hatched. Years pass before any turtle turns back west, toward the beaches of its birth. On this side of the world, the ocean writes its own long detour. Green turtle hatchlings follow a broadly similar, early path, adrift among the same currents and floating sargassum. For now they eat much as loggerheads do, taking small drifting creatures wherever they find them. Only later, once settled near coastal shallows, does their diet shift toward seagrass and algae. That shift marks one of the clearest differences between the species. Before then, every hatchling, whatever its future diet, is simply a small forager adrift at sea. Champs Ridley hatchlings enter the Gulf of Mexico's own private current system. This smaller sea loops within itself, circling rather than crossing an open ocean. A hatchling here may finish its earliest travels entirely inside the Gulf, never touching the wider Atlantic system at all. The loop is tighter, faster, more contained. Fewer miles, but the same uncertainty guides every turn. Leatherback hatchlings, unlike their relatives, head almost straight for deep water. There is little pause at the surface, little drifting near shore. Something in their small bodies seems built for depth from the very first hour. Within a day, many are already swimming over water thousands of meters deep. No shallow apprenticeship for this species, only the open dark below. Somewhere beyond these walls, a sound arrives and fades again, wind against a window, or a house easing into its own weight. It comes without hurry and asks nothing of you. Let your shoulders sink a little further into whatever holds them. Let your breath find its own long rhythm, unbothered by counting. The sound will return and recede, and neither matters. You are only here to rest. One tracking device, fitted to a young turtle decades ago, was expected to fail within weeks. Its battery kept sending signals long past that estimate, month after unexpected month. Researchers watching the returning points realized the turtle had crossed far more ocean than anyone had planned for. The equipment had simply outlasted its own forecast. That quiet overachievement rewrote what biologists thought young turtles were capable of. Satellite tags today are smaller than a coin, light enough to ride unnoticed on a turtle's shell. Each one sends a brief signal skyward whenever the turtle surfaces to breathe. Engineers shaped these tags to shed drag, so the turtle barely feels their weight. What once required bulky housing now fits in something a child could hold in one palm. The ocean gave up its secrets a little more easily after that. Early tags were heavier, awkward things, strapped on with more hope than precision. Many fell away within days, lost somewhere in open water. A turtle might carry one for a single transmission before it slipped free and sank. Researchers learned patience from these failures, testing shape after shape across years of trial. Each lost tag still taught something, even in its silence. Each transmission becomes a single point of light on a researcher's screen, appearing without warning after hours or days of nothing. One point rarely tells much on its own, but strung together across weeks, the points begin sketching a path no one had walked before. A screen once dark with waiting slowly, filled with a turtle's whole invisible route made visible. A single loggerhead's track, pieced together over its lifetime, can span tens of thousands of kilometers. That distance would circle the Earth more than once if laid end to end. Yet no single swim covers it. The total gathers slowly across years of feeding, resting, and returning. Distance for a turtle is something accumulated rather than rushed. The ocean simply keeps adding to the ledger. Juvenile turtles eventually leave the open sea behind for shallower coastal waters. The wide, wandering currents of youth give way to something more settled and known. Reefs, bays, and seagrass beds begin to replace the endless blue of the open gyre. This move marks a turning point few witnesses ever see directly. It happens gradually, turtle by turtle, far from any watching eye. This shift from open ocean wandering to coastal foraging can take 5 to 10 years, depending on the species and the turtle. There is no single signal that marks the change, no clear gate a turtle passes through. Growth, size, and instinct seem to align gradually until the shallows simply start to make more sense. By the time it settles near a reef or a bay, a turtle has already spent years becoming ready for it. Near shore, the ocean offers a different kind of table. Neritic waters hold crabs tucked in sand, seagrass swaying in shallow light, and sponges clinging to old reef. What a turtle finds here depends entirely on which species it is. A hawksbill and a green turtle, feeding meters apart, might never touch the other's meal. The coast provides, but it provides selectively. Growth changes pace once a turtle settles into coastal life. Where the open ocean once fueled quick gains, the shell may now thicken by only a centimeter or two each year. Energy shifts from growing larger to simply staying alive and steady. A turtle at this stage is patient in a way its younger self never had to be. Time, here, moves differently. Somewhere inside a turtle's own skeleton, its years are written down. Bones such as the humerus hold layered rings, laid one atop another as seasons pass. Researchers slice a thin cross-section to count them, much like counting inside a stump. The number of rings gives a rough measure of age no outward glance could offer. A turtle carries its own calendar, hidden beneath the surface. Let the warmth begin somewhere small, perhaps the center of your chest, and let it spread outward from there. Feel it move first into your shoulders, loosening what they've carried all day. Then let it travel down each arm, reaching your fingertips until they feel heavy and full. It settles into your stomach next, a low, steady glow with nowhere urgent to be. Let it drift into your hips, your thighs, your knees, sinking further with each breath. By the time it reaches your feet, your whole body may feel like it's resting in warm, still water. Stay there a while. There is only this warmth, and your breath, and the dark. Bone rings and tree rings share more than a passing resemblance. Both form in bands, one added with each turn of the seasons. A tree slows its growth in winter, leaving a thin, dark line behind. A turtle's bone does something similar in leaner months, marking the pause before growth resumes. Two very different lives, keeping time in nearly the same quiet way. Coral reefs suit hawksbills especially well. Their narrow, pointed beaks slip into crevices too tight for broader jaws, reaching sponges tucked between coral branches. Many of these sponges carry compounds toxic to other animals, yet hawksbills feed on them without apparent harm. Where the reef grows dense and colorful, a hawksbill often isn't far. The reef, in turn, depends a little on the grazing it receives. Green turtles graze seagrass meadows much the way cattle move across an open field. They crop the blades close and often, returning to the same patches again and again. This steady grazing actually keeps the meadow healthier, encouraging new growth rather than choking it. Seagrass beds, shaped by generations of grazing turtles, look different from those left untouched. The turtle, in this sense, tends the pasture it feeds on. Loggerheads carry a different kind of tool entirely. Their jaws are broad, thick, and built for crushing rather than nibbling. Crabs, clams, and other hard-shelled prey stand little chance against that pressure. A loggerhead's skull, in fact, is noticeably wider than a green turtle's, shaped by generations of cracking shells instead of clipping grass. Diet over time leaves its mark on the very bones of the head. Leatherbacks stand apart from every other turtle on this list. Almost their entire diet is jellyfish, a food both watery and nutritionally sparse. Most animals would struggle to survive on something so thin in substance, yet leatherbacks have built an entire migratory life around chasing these soft, drifting clouds through open water. Fragility, for this species, has become a way of life rather than a weakness. To make up for such a thin diet, a leatherback simply eats enormous amounts. In a single day, it may consume jellyfish equal to its own body weight. This means constant feeding, almost without pause, as it moves through waters where jellyfish gather. The math only works because the ocean, in certain places and seasons, offers jellyfish without limit. A leatherback's hunger, in this light, looks less strange and more like careful arithmetic. Flatback turtles rarely travel beyond the waters of northern Australia. Unlike loggerheads or leatherbacks, they skip the long ocean crossings entirely, staying close to the continental shelf their whole lives. Their eggs hatch on Australian beaches, and their feeding grounds lie in the same soft, muddy shallows nearby. This shorter range doesn't make their story smaller, only differently shaped. A single coastline holds everything a flatback will ever need. Along certain beaches in Costa Rica and India, tens of thousands of olive ridleys come ashore within the same handful of nights, Sand disappears beneath shifting bodies, flippers overlapping flippers in the dark. Few other reptiles gather in numbers so large or so tightly timed. Researchers who witness it describe the scale as overwhelming despite its steady rhythm. For one brief stretch, an entire beach becomes turtle. 7 species share one ocean, yet each has settled into its own particular version of it. Hawksbills claim the reef, greens the meadow, leatherbacks the open blue far from shore. Flatbacks hold a single coastline. Olive ridleys favor Pacific and Indian shores in great numbers. Loggerheads range wide, crossing entire ocean basins. Nothing forces this division. It simply happened, generation after generation, until each turtle found its place. A young turtle that has spent long stretches afloat often wears a second skin of algae across its shell. Green strands cling to every ridge, softening its outline against the floating mats around it. Fish, crabs, and debris blend together at the surface, and the algae helps a small turtle vanish inside that mixture. Predators scanning the surface see only another clump of weed. Camouflage, for a hatchling, can be a coat it never asked for. A candle in an empty room has burned down to its last inch of wax. Its flame no longer reaches upward, just holds close and low against the wick. No draft touches it, no hand hurries it along. It only keeps its own small glow a little longer, asking nothing of the dark around it. Let your breathing settle into that same low, steady flicker, in, then out, then in again. You, too, can simply keep your own small glow tonight, needing nothing further from the day. Magnetic fields wrap the entire planet, invisible yet unbroken from pole to pole. They pass through rock, water, and flesh without resistance, felt by almost nothing that lives on land. Compasses respond to them, so, it turns out, do certain animals. Birds, some fish, and turtles all seem tuned to this hidden structure in ways no eye could ever detect. The ocean a turtle swims through is layered with a map no one can see. Sea turtles seem able to detect this field in astonishingly fine detail. Tiny shifts in its strength or angle, changes far too small for a compass needle to register, appear to register with a turtle's body. No one has caught the sense working in real time, but the behavior it produces is measurable, consistent, and repeated across species. Somewhere inside a turtle, the planet's magnetism is being read like a page. 2 pieces of information, latitude and the angle at which the field tilts downward, seem to combine into a kind of coordinate a turtle can read. Near the poles, the field dips steeply. Near the equator, it lies nearly flat. A turtle sensing that tilt, alongside the field's overall strength, gains a rough sense of where on the globe it happens to be. It isn't a map in the human sense, no lines or names. It's closer to an inherited compass with 2 needles instead of 1. This ability seems present from a turtle's very first swim, long before any lived experience could have taught it. Hatchlings only hours old, tested far from any coastline, already orient as though reading the field around them. That leaves inheritance, not learning, as the most probable source. A sense this immediate suggests it was written into the turtle before it ever broke free of its egg. Kenneth Lohman, a biologist studying magnetic orientation, built a tank ringed with wire coils in his laboratory, each coil capable of generating a magnetic field matching any point on Earth. Into that tank he placed loggerhead hatchlings only days old, tracking which way each one chose to swim. He hadn't hatched them anywhere near the ocean they had never seen. The coils alone would tell him what, if anything, the turtles carried inside them already. Hatchlings in that ringed tank swam as though the coils around them were the true ocean. When Lohman altered the field to match a point off Florida's coast, the young turtles turned and swam south, toward Africa, exactly as a wild loggerhead would from that same latitude. Changed the field again, and their heading shifted with it. The turtles had never left the laboratory, yet their bodies answered to a planet they had never actually swum. This single experiment suggested something larger than orientation. If hatchlings only days old already carried a working magnetic map, that map could not have been learned from swimming the ocean. It must have arrived some other way, passed down before the egg ever cracked open. A turtle's sense of place, it seemed, was inherited rather than built through experience. The map came first, the journey came after. No single organ has yet been identified as the source of this sense. Researchers have searched a turtle's skin, its inner ear, even tissue near its brain, without settling on one clear answer. The sense behaves consistently, appearing in every hatchling tested, yet its physical seat remains unmapped. Biology can describe what a turtle does. It cannot yet say, with certainty, how the doing happens. Magnetite, a naturally magnetic mineral, offers one candidate for where this sense might live. Tiny crystals of it have turned up in the tissues of several migratory species, turtles included. Such crystals could, in theory, shift with a changing field and pass that signal along to nearby nerves. The idea remains unconfirmed, resting more on possibility than proof. Even so, it stands as the leading guess among several offered so far. Turtles moved artificially, far from their expected route, have still managed to find their way back onto it. Researchers relocating loggerheads hundreds of kilometers off course watched many correct their heading within days, aiming again for the same coastal target. Such recoveries argue for a map, not simple habit or memory of familiar landmarks. A turtle set down in unfamiliar water still seems to know, in some fashion, where home lies. Let your jaw loosen now, just slightly, wherever it has been holding on. Let your eyelids grow heavier, until keeping them open feels like more effort than closing them. Behind closed eyes, there is only a soft, shifting dark. No shapes to follow, no scene to complete. Let your forehead smooth itself, line by line, the way still water settles once the wind has passed. Breathe out longer than you breathed in. There is only this dim, easy quiet, and no reason to leave it yet. A turtle's magnetic sense likely works alongside other cues rather than standing alone. Scent carried on, ocean currents, the pull of moving water itself, even the pattern of stars overhead may all contribute pieces to the same journey. No single sense seems to carry the whole burden of navigation. Together, they layer into something more reliable than any one cue could offer by itself. Wave patterns continue offering directional information long after a hatchling leaves the shore behind. Waves generally roll in the same direction as they approach a coastline, shaped by prevailing winds and the shape of the seafloor beneath them. A young turtle swimming against that grain, or with it, may be reading a kind of current-born compass. This cue fades the farther a turtle travels from shore, but near the coast it appears reliable enough to matter. Low-frequency sound, generated by breaking surf, may offer another clue as a turtle nears land. Waves crashing against a coastline produce a rumble far below what human ears can register, one that can carry for a considerable distance through water. A turtle approaching from open sea might sense that rumble growing steadily louder, a kind of acoustic beacon pointing it toward shore. Sound, in this way, could complete part of the picture that scent and magnetism only sketch. Certain cues might only become useful within the final few kilometers of a long journey. A magnetic map may guide a turtle across an entire ocean basin, while scent, sound, and wave pattern take over only once the coastline draws near. Navigation, seen this way, unfolds in stages, each sense handing the task to the next as distance shrinks. The whole ocean is crossed by one kind of knowing. The last stretch is finished by another. Navigation, it seems, layers many senses rather than relying on one. Field angle, scent, sound, and current all contribute something, and none appears sufficient alone. Researchers who study this describe it less as a single compass and more as a chorus of faint signals. Together, they narrow the odds of a very long journey ending in the wrong place. Leatherbacks undertake some of the longest known migrations of any reptile. Their bodies are built for open water, dark and streamlined, without the hard shell other turtles carry. They range across entire ocean basins, following jellyfish blooms wherever they drift. Few animals on Earth cover so much distance simply to eat and to return home. A single leatherback tracked from Indonesia crossed the Pacific to the coast of Oregon. Her path wound through open water far from any coastline, guided by currents and whatever inner sense she carried. Scientists followed her signal for months as the dots on their screen inched steadily eastward. It remains one of the clearest single records of just how far one turtle can travel. That journey covered roughly 20,000 kilometers, over about a year and a half. She swam through warm equatorial water and cooler northern currents without pause for rest on land. No shelter, no shoreline, only the sea beneath her the entire time. Distances like this quietly rewrite what people once assumed a reptile could endure. Loggerheads crossing the Atlantic connect nesting beaches in Florida to feeding grounds off Africa. Hatchlings that once drifted the gyre as tiny wanderers return, years later, as adults tracing much the same wide loop. The ocean that once carried them passively now carries them by choice and memory both. Florida's shore and Africa's coast, joined by nothing but water and instinct. Green turtles in the Pacific travel between Hawaiian feeding grounds and remote nesting atolls. The distance between the two can stretch for hundreds of kilometers of open water, with nothing but reef and current in between. They graze quietly among the islands for years before making the crossing again. Each atoll, however small, holds the memory of where they began. Notice, if you can, the slow rise and fall of your own breath right now. There is no need to change it, only to follow it, the way a wave follows the shape of the shore. Each exhale can grow a little longer than the one before it. Let your shoulders sink further into whatever is holding you. Nothing waits for you tonight but rest, drifting in on its own current. Ascension Island draws green turtles across nearly the entire width of the South Atlantic. Females leave feeding grounds off Brazil and swim east for weeks toward a place barely larger than a shipwreck on the horizon. No coastline guides them for most of the way, only open water and whatever inner map they carry. Few migrations anywhere ask so much of so small a destination. That island is barely visible from the sea, a speck amid open water. Its highest point rises just enough to break the horizon on a clear day, nothing more. Sailors once used the same faint silhouette to correct their course across empty ocean. A turtle, somehow, manages the same feat without chart or compass in hand. Finding such a small target after years away still astonishes researchers who track it. Tag after tag confirms the same result, females arriving within a few kilometers of that narrow shoreline. Some have proposed a fine-tuned mix of magnetic sensing and scent carried on the current, though the full explanation remains unsettled. What is certain is the outcome itself, repeated season after season without fail. Emps ridleys migrate almost entirely within the Gulf of Mexico, a smaller stage for a smaller range. Their nesting beaches, feeding grounds, and open water routes all sit inside one enclosed basin. A hatchling here never crosses an ocean the way a loggerhead might. Its whole migratory story fits inside waters bounded by 3 coastlines. Even so, the currents it rides are no less demanding for being contained. Off the Pacific coast of Central America, olive ridleys travel shorter, steadier loops. They tend to stay within a few hundred kilometers of the beaches where they hatched. Their feeding grounds sit close enough that a season's migration barely stretches their limits. Life for an olive ridley favors rhythm over distance. Each loop repeats with little variation year after year. Hawksbills tend to stay closer to reefs, their migrations modest by comparison. Coral structures offer both food and shelter, so there is little reason to wander far. A hawksbill might spend most of its adult life within sight of the same reef system. Its journeys are measured less by ocean crossings than by movement between reef and shoal. Distance, for this species, rarely defines the story. Australian continental waters rarely see flatbacks travel far beyond them. This species keeps almost entirely to the shelf surrounding its home continent, never venturing into the open ocean crossings common elsewhere. Its nesting beaches sit close to its feeding grounds, separated by short, familiar swims. Among all 7 species, the flatback keeps the smallest known migratory footprint. Its whole life plays out within a single regional stage. Distance, then, is not a single rule, but a spectrum across 7 species. Some turtles barely leave the water they were born into. Others cross entire ocean basins over the course of a single year. Between these extremes sit species, content with modest, repeating loops. What unites them is not the length of the journey, but the certainty with which it repeats. Longer migrations often mean longer years before an adult first returns to nest. Distance and patience seem bound together in ways still being mapped species by species. A turtle traveling farther as a juvenile also tends to take longer growing into readiness. Time, much like water, seems to stretch with the length of the road ahead. The largest journeys ask the most of those who complete them. A loggerhead may not nest for the first time until it is 20 or 30 years old. Decades pass between the first frenzied swim from shore and the first crawl back onto sand as an adult. Much of that time unfolds far from any beach, spent foraging across distant coastal waters. When the return finally comes, it closes a gap most animals never need to bridge. Few creatures wait so long to complete a single circle. Let the weight of your body settle now, piece by piece. Feel your feet grow heavy first, sinking into the mattress beneath them. Let that heaviness climb slowly upward, through your legs, your hips, your chest. Your arms follow, resting fully, asking nothing of you. Even your head grows heavier against the pillow, held completely, needing no effort at all to stay there. Early tag returns from the 1950s came back so slowly that researchers doubted the turtles had traveled far at all. Weeks or months might pass with no word, and many tags were never recovered at all. When a report finally arrived, it often came from a fisherman or a beachcomber rather than a scientist. The delay left early researchers guessing at ranges far smaller than the truth. Only patience, spread across many seasons, revealed how wrong those first guesses had been. One tagged green turtle turned up years later on a beach far from where it was marked. The distance between the 2 points surprised even the biologists who had placed the tag themselves. No one expected an animal to cover so much open water and still find its way to shore with such accuracy. That single report traveled slowly through letters and notebooks before reaching anyone who understood its significance. It became one small thread in a much larger, still-forming picture. That single recovery hinted at ocean-scale movement long before satellites existed. No transmitter had traced the turtle's path. No screen had shown its progress day by day. Only the metal tag and a distant beach told the story after the fact. Yet the implication reached forward decades, shaping every study that followed. A quiet clue, waiting patiently to be understood. Tag numbers stamped in metal outlasted many of the turtles that wore them. A shell might be lost to a predator or the sea, but the small disc sometimes washed ashore intact, its engraving still legible. Fishermen occasionally found these tags years after the animal itself had died. Each one carried a code linking back to a distant researcher's logbook. In this way, a turtle's story could continue even after its own ending. Modern tags now relay a turtle's dive depth along with its position. A small transmitter fixed to the shell can send both numbers together, stitching motion into 3 dimensions instead of 2. Researchers watching a screen see not just where a turtle has been, but how far beneath the surface it traveled. This pairing turned flat migration maps into something closer to a living record. Depth became a second language. The ocean could finally speak. Depth readings show turtles resting near the surface for long stretches at sea. Between dives, many float just beneath the waves, barely moving, conserving energy for the journey ahead. This surface time often falls at night, when predators are harder to spot and the water feels calmer. Instruments capture these pauses as flat lines on a depth chart. Even a great traveler needs stillness woven through its miles. A turtle can also dive several hundred meters when foraging or avoiding danger. These deeper descents interrupt the long stretches of surface rest, sending the animal down through colder, darker water. Pressure at such depths would trouble most reptiles, yet a turtle's body absorbs the change without apparent strain. Food, safety, or curiosity might each explain a particular dive. The ocean's middle layers remain part of its ordinary range. Leatherbacks have recorded some of the deepest dives of any air-breathing reptile. Tagged individuals have descended beyond 1,000 meters into water utterly without sunlight. At that depth, the pressure alone would crush many bodies unaccustomed to it. A leatherback's soft, flexible shell may help it withstand what a rigid one could not. Few creatures carrying lungs venture so far from the air they depend on. Slower heart rates let a turtle conserve oxygen through these long dives. Between breaths at the surface, its pulse can drop to only a few beats each minute, stretching a single lungful of air across many minutes underwater. Blood flow shifts toward the organs that need it most, leaving the rest to wait. This measured pacing turns a limited breath into a long, patient descent. Efficiency, more than power, carries a turtle through the deep. Blood chemistry shifts to tolerate carbon dioxide levels that would trouble most animals. As a dive lengthens, carbon dioxide builds in the tissues, yet a turtle's body resists the usual urgency. This triggers elsewhere certain proteins in its blood buffer, the change holding discomfort at bay. This tolerance lets the dive continue well past where another creature might panic. Patience, it seems, is written into the blood itself. Somewhere far off, a low hum drifts in and fades, like wind moving through a chimney no one built. It arrives without asking anything of you and leaves the same way. Let your breath match its slow retreat, in, then out, then quiet again. Nothing nearby needs your attention now. The hum returns once more, fainter this time, and you sink a little further into the warmth beneath you. A turtle's shell shape reduces drag across thousands of kilometers of swimming. Its smooth, streamlined curve lets water slip past with little resistance, shaped by countless generations spent moving through open sea. Even small ridges and contours seem tuned to lessen turbulence rather than create it. This quiet efficiency saves energy that would otherwise be lost to friction. A body built for distance, long before distance was ever measured. Front flippers act like wings, sweeping through water the way a bird's wings sweep through air. Each stroke pushes down and back, generating lift instead of drag. The motion is broad, sweeping, almost effortless to watch. Muscle built for endurance drives this rhythm across thousands of kilometers. It is flight translated into water. Rear flippers steer, adjusting course with barely any visible motion. A slight tilt, a small twist, and the whole body shifts direction. Nothing about it looks urgent or forced. This subtlety saves energy that a wider turn would waste. Precision, not force, keeps a turtle on its long, invisible line. This efficient design lets a turtle cover great distances on relatively little energy. Wings for propulsion, rudders for steering, a shell shaped to slip through resistance. Together, they turn ocean crossings into something almost economical. No wasted thrashing, no sudden bursts unless danger demands them. Distance becomes a matter of patience, not power. A resting metabolism lets some turtles glide for hours without surfacing. Muscles ease into a low, steady hum of activity. Oxygen use drops to match the stillness. This lets a turtle drift on a current rather than fight it. Rest, out here, is still a kind of motion. Ocean currents remain a partner throughout adulthood, not just in the hatchling years. What once carried a drifting yearling now carries a full-grown traveler. Adult turtles still lean into these moving rivers of water rather than crossing against them. Choosing the right current can shorten a journey by weeks. The sea, in this way, still does much of the work. The Gulf Stream carries migrating loggerheads much of the way north along the Atlantic coast. This warm river within the ocean moves faster than the surrounding water, offering a natural boost. Turtles riding it save considerable effort compared to swimming the open sea alone. Their paths often trace its curves with striking accuracy. It is less a route they choose than a route they borrow. Off South Africa, the Agulhas current shapes the paths of turtles feeding nearby. This current runs strong and fast along the continent's edge, bending the routes of animals that cross it. Loggerheads and leatherbacks alike adjust their swimming to work with its pull rather than against it. Even a strong swimmer respects a current this forceful. The coastline here writes its own set of rules. Wind-driven surface currents shift slightly season to season, and turtles seem to adjust their paths in response. A shift in prevailing winds can nudge a current's edge by a measurable distance. Migrating turtles appear to sense these small seasonal changes and bend their course accordingly. No one has mapped exactly how finely this adjustment is made. Still, the correspondence between wind, water, and wandering turtle is hard to miss. Rather than a straight line, a turtle's route is closer to a negotiation with moving water. Every crossing weighs the shortest path against the easiest one. Sometimes the longer route, carried by a strong current, costs less energy in the end. A turtle's course, viewed from above, often curves in ways a map alone wouldn't predict. Distance and effort out here are rarely the same thing. Feel warmth begin to pool low in your body now, somewhere near your stomach, spreading outward like sunlight through water. It moves up through your chest first, loosening whatever held tight there, then down through your hips, your thighs, your calves, releasing each in turn. Your hands grow heavy, your feet grow heavy, resting exactly where they are. Let this warmth settle into your shoulders last, easing them down into the mattress. There is only this slow spread of warmth, and the dark, and your breathing, easy and even, carrying you further from the surface of the day. Storms can push a migrating turtle hundreds of kilometers off its intended path. Wind and heavy swell overwhelm even a strong swimmer's steady rhythm. A turtle caught in such weather simply rides it out, conserving strength rather than fighting the current. Once the storm passes, it begins correcting course again, drawing on senses built for exactly this kind of detour. The ocean rarely offers a straight road for long. Cold fronts occasionally strand turtles too sluggish to swim away in time. When water temperature drops fast, especially in shallow bays, a turtle's body cannot keep pace with the change. It stops swimming, drifts with the tide, and sometimes washes ashore still alive, but barely responsive. These events cluster in winter along certain coastlines, following patterns tied to weather more than chance. Cold stunning slows a turtle's body until it can barely move at all. Heart rate falls, muscles stiffen, and the animal drifts helpless on the surface or seafloor. It looks, to an untrained eye, like death, though the turtle may still recover. Warmer water and time are usually all that's needed. Even so, a turtle in this state cannot help itself. It can only wait. Rescue networks in some regions now watch for these stranded turtles each winter. Volunteers walk beaches after cold fronts pass, checking known landing spots where currents tend to deposit weakened animals. Turtles found in time are warmed gradually in shallow tanks before release. This work, quiet and repetitive, has saved thousands of individuals across many nesting seasons. Sharks and orcas take a share of migrating turtles, mostly the young or weak. Open water offers little cover, and a slower or smaller turtle draws more attention than a strong adult. Predation like this has shaped turtle behavior for millions of years, favoring speed, timing, and the safety of numbers during vulnerable crossings. It remains a steady, unremarkable part of ocean life. A hard shell offers real protection, but not full safety from large predators. Bone and keratin can turn aside many bites, but not all. Orcas and larger sharks have jaws, strong enough to breach even a mature carapace on occasion. Most encounters end without harm, simply because most predators move on to easier prey. Still, the shell is armor, not immunity. Fishing lines and nets present a newer kind of hazard along old routes. Where migration paths cross busy fishing grounds, gear left drifting or set deep can catch a turtle unaware. Many fleets now use modified nets and hooks designed to let turtles escape more easily. The routes themselves haven't changed in ages. What moves through them had. Turtles have followed some of these paths, longer than the boats crossing them. Fossil evidence places turtle migration back tens of millions of years, long before any hull first parted these waters. Shipping lanes, fishing zones, and cargo routes are recent additions layered over something far older. The turtle's map predates the ships that now share its lines. Natural hazards, long-followed migration, and moving water combine into a single test each year. Storms, cold, predators, and human activity all press against the same instinct that has carried turtles across oceans since before memory. None of these forces act alone. They overlap, season after season, along routes turtles never chose to make easy. Surviving the year means surviving all of it together. Generation after generation, somehow, enough turtles complete it to keep the pattern alive. Most hatchlings never reach adulthood, and many adults never finish a single migration unscathed. Yet enough do, season after season, to keep beaches filled with new nests each year. The math is unforgiving, but the outcome, so far, has held. It's a fragile kind of endurance, and a lasting one. And somewhere above the water tonight, a thin line of mist hangs over the tide, neither rising nor falling. It drifts the way a held breath drifts once you finally let it go. Your shoulders can loosen now, the way that mist loosens from the surface. Nothing pulls at it. It simply hangs there, patient in the dark, going nowhere in particular. You can rest the same way, adrift in the warm dark, held by nothing more than stillness itself. Homing draws an adult turtle back toward the beach of its own birth. After years spent circling ocean basins, feeding, growing, surviving storms and long dives, something turns her course toward a single stretch of sand. It is not any beach. It is the one she left as a hatchling. Few animals travel so far, only to arrive at so precise a point of origin. This return can happen after a decade or more of separation from land. A female may spend 20, even 30 years at sea before she ever sets flipper on sand again. The ocean in between holds storms, seasons, entire cycles of feeding grounds visited and left. yet somewhere inside her, the beach waits, unchanged in memory, even as the sea around her keeps shifting. Archie Carr first proposed that turtles navigate home using a kind of inherited memory. Working through the middle of the 20th century, he noticed that females returned again and again to the very beaches where they themselves had hatched. No instrument then could explain how. Carr suggested the answer lived inside the turtle itself, carried forward from its earliest days on sand. His idea, once doubted, became the seed of natal homing research still active today. Colleagues questioned how a hatchling barely minutes old could carry any lasting impression of a beach. Decades of tracking since have only deepened the question rather than closing it. Carr's early proposal, dismissed by some at first, now anchors an entire field of study. Chemical traces absorbed as a hatchling may linger faintly in an adult's memory. Minerals, plant compounds, even subtle scents carried in coastal runoff could imprint themselves during those first frantic minutes at sea. Years later, the same faint signature drifting from shore might feel familiar, though no one can yet say exactly how strongly it registers. The nose, in this telling, becomes a kind of long-delayed map. No one has fully confirmed which single cue turtles trust most for this final approach. Magnetic signatures, chemical traces, wave patterns, and sound may all overlap in these last kilometers. Untangling one thread from the rest has proven difficult in open water. It remains an open question, one that keeps drawing researchers back to the same shallow surf year after year. A turtle, nearing her home beach, often circles offshore for days before coming ashore. She moves in wide, unhurried loops just beyond the surf line, neither approaching nor retreating far. Something in this waiting seems deliberate rather than aimless. Only after this slow circling does she finally turn toward the sand. This offshore waiting period may let a turtle confirm subtle coastal signals before committing to land. Temperature shifts, sand runoff, even the particular rhythm of local waves could offer final confirmation that this is the right shore. A mistaken landing wastes precious energy and risks exposure to predators. Better, perhaps, to circle a while longer and be certain. Mating usually happens in the water near the nesting beach, not on land. Males gather offshore during the nesting season, waiting for females to arrive from their long journeys. Pairs come together briefly in open water, well before any crawl toward sand begins. Land, for a turtle, is reserved for something else entirely. Several males may court a single female before she ever settles near the beach where she was born. She might mate with 2, 3, sometimes more partners across the season's early weeks. Genetic studies of hatchlings from one nest have found multiple fathers represented within the same clutch. Her body simply stores what she needs, releasing it later in careful measure. Let your jaw loosen now, just slightly, the way a held door eases open on its own weight. Feel whatever tightness lives behind your eyes begin to thin out, unnoticed, like fog lifting off still water. Your eyelids may already feel too heavy to matter. Behind them, there is only a warm, wide dark asking nothing of you. Let your breath find its own rhythm there, unwatched, unhurried, entirely its own. Males, once grown, rarely set foot on land again after their own hurried scramble as hatchlings. They spend their entire adult lives at sea, feeding, migrating, mating in open water. No crawl up a beach, no digging, no burden of nesting ever falls to them. Their part in the story, after that first sprint to the surf, unfolds entirely beneath the waves. Females, then, are the ones who complete the full shape of the migratory circle. They leave the sand as hatchlings and, decades later, return to sand as mothers. That return closes a loop no male will ever finish in the same way. It gives the whole migration its final grounded step. A female arriving at night chooses her nest site less by sight than by feel. She noses along the sand, testing its give beneath her flippers. Slope, dryness, distance from the tide line all register through touch rather than vision. Instinct narrows her search long before conscious choice ever could. Once satisfied with a spot, she begins by scooping out a shallow body pit with all 4 flippers. This first depression simply settles her weight low against the sand. Only after that does she dig the true nest chamber, narrower and deeper, shaped almost entirely by her rear flippers alone. The 2 structures serve very different purposes. How wet the sand feels and how coarse its grains are, both shape where she ultimately digs. Sand that is too dry collapses before a chamber can hold its form. Sand packed too tightly resists her flippers entirely. Somewhere between those extremes, she finds ground firm enough to trust. Laying the eggs themselves often takes less than an hour, despite everything that came before it. Each egg drops in near silence, one after another, into the waiting chamber. Compared to the labor of digging, this part unfolds almost gently. Her body seems to know exactly how to pace itself. When the eggs are laid, she begins covering the nest, flinging sand backward with steady, deliberate motion. She tamps it down, then scatters more sand widely around the area, blurring the true location. To an untrained eye, the disguised patch looks like nothing more than disturbed ground. This concealment may be her last act of protection before returning to sea. Nearly all of this, from choosing ground to covering the nest, happens in darkness. Touch, weight, and instinct guide her far more than sight ever could. The beach around her stays hushed, except for the soft shift of sand. When she finally turns back toward the water, she leaves behind a chamber holding the next generation's beginning. Nesting season for one female rarely ends with a single clutch. Within a few months, she may crawl ashore several separate times, each visit adding another chamber of eggs to the beach's hidden count. Between these nights, she rests offshore, conserving strength for the next climb. Spreading her eggs this way improves the odds that at least one clutch survives whatever the season brings. Roughly 2 weeks typically separate one clutch from the next. In that gap, she feeds and rests in waters near the coast, gathering enough reserve to shape another set of eggs. The interval gives her body time to recover from the labor of digging and laying. By season's end, these 2-week gaps can add up to 4 or 5 separate nests. Notice, for a moment, the pace of your own breath. Each inhale lifts the chest just slightly, then lets go on its own. There's no need to change it, only to notice how it slows the longer you listen. Let the exhale stretch a little longer than the breath before it. With each release, your shoulders settle a little deeper into wherever you're resting. The night around you asks nothing of you but this slow rhythm of air moving in and out and in again. Total eggs across a season's clutches can number in the hundreds for one female. A loggerhead might lay 4 clutches of roughly 100 eggs, adding up to some 400 eggs before the season closes. Green turtles can lay similar totals, spread across their own handful of visits. Numbers like these look enormous, only until measured against what survives. Only a small fraction of hatchlings from any nest will reach adulthood. Out of every 100 that scramble down the sand, the ocean and its many predators claim nearly all of them before maturity. This is not failure so much as the ordinary arithmetic of a species built on abundance. A single survivor, decades later, can still return to lay her own eggs on this same shore. This low survival rate is balanced by sheer volume, laid over many seasons. A female who nests for 30 years across her lifetime may produce tens of thousands of eggs in total. Even with steep losses at every stage, that scale leaves enough turtles standing at the end. Evolution, in this case, favored quantity over any single guarantee. Between nesting seasons, a female may rest 2 or 3 years before returning to lay again. This pause lets her rebuild the energy spent on migration, courtship, and the physical demands of egg production. Unlike some animals that breed each year without fail, sea turtles space their effort more widely. The rhythm is stretched across long stretches of ordinary swimming and feeding. At rest may reflect the sheer energy cost of migration and reproduction combined. Building yolk for hundreds of eggs draws heavily on a turtle's fat reserves that took years to accumulate. Add to that the distance many females swim just to reach a nesting beach, and the toll becomes clear. Recovery time, then, is less an indulgence than a biological necessity. Nesting beaches themselves are surprisingly few relative to a species' total range. A loggerhead might forage across thousands of kilometers of coastline yet nest on only a narrow handful of preferred shores. This funneling concentrates each species' entire future onto a small strip of sand. Protecting those few beaches carries weight far beyond their modest size. Certain beaches host thousands of females arriving within the same short window. Along parts of the Pacific coast of Central America and in pockets of the Indian Ocean, the sand can seem to move with turtles on a single night. Such concentrated arrivals turn a quiet shoreline into one of the ocean's most crowded gatherings, if only for a season. This mass nesting, known as an arrabada, still puzzles the researchers who study it. Thousands of females arrive within days of each other, sometimes within hours, on beaches they may not have visited in years. What synchronizes such an enormous crowd remains only partly understood. Marine ecology has no final answer for why the timing holds so tightly across so many individual lives. Moon phase and tide height may both play a role in triggering the gathering. Higher tides carry females closer to the dry, stable sand they need for a nest. Bright moonlight might help them find the shore, though clouded nights host arrabadas too. No single trigger has been confirmed, and the true cause may be several signals arriving together. During a large arrabada, a later female may dig straight into an earlier clutch while digging her own. The sheer density of nests leaves little untouched sand for those who arrive last. Eggs get overturned, buried deeper, or scattered by accident rather than any intent. It is simply what happens when so many turtles share so little shore in so short a time. Let your body settle now, heavier with each breath you release. Feel your feet grow still, then your calves, then your knees, sinking a little further into whatever holds you. Let that heaviness climb slowly upward, through your hips, your back, your shoulders, until even your hands feel too full of rest to move. There is only this weight now, spreading warm and even, asking nothing of you but to stay. A single tagged female returned to the same nesting beach for more than 20 years. Researchers first marked her as an adult, expecting perhaps a season or two of data. Instead, she kept coming back, one nesting season after another, her tag number logged again and again in field notebooks. Her long, patient return became one of the clearest records of a turtle's working life. Records like hers gave researchers their first real sense of how long a turtle's nesting years might stretch. Before such long-term tagging, no one had firm numbers for how many seasons a single female might return. Her repeated appearances spaced across decades offered something rarer than a single measurement, a timeline. From timelines like this, a rough picture of turtle longevity began to take shape. A sea turtle can live many decades, with some estimates reaching beyond 70 years. Growth slows drastically after adulthood, so an old turtle looks much like a younger one, only worn smoother by time, where patterns on the shell, more than size, sometimes hint at age. Such a long life gives migration room to repeat itself many times over. Migration, then, is not one journey but a repeated one across a very long life. The same currents, the same feeding grounds, the same distant beach, visited again and again across changing decades. Each crossing echoes the ones before it, though the ocean itself shifts slightly each time. A turtle's life becomes a long refrain rather than a single verse. Each return to the nesting beach closes one loop while quietly opening another. The eggs laid this season will, if they survive, begin the very same cycle from the very beginning. What ends for one generation becomes the start of the next, folded into the same stretch of sand. The shoreline holds both endings and beginnings without any need to separate them. Hatchlings from this year's nests will one day repeat the very same passage. They will drift with currents, grow slowly in open water, and if fortune allows, return as adults to this same narrow shore. The distance between their first crawl and their eventual homecoming spans most of a turtle's long life. Somewhere ahead of them, the whole journey waits to begin again. Fossil evidence suggests turtles have followed ocean routes for tens of millions of years. Shell fragments and ancient trackways in old sediment layers hint at journeys much like the ones happening tonight. Paleontologists studying these fossils see the same basic body plan, largely unchanged. Flippers, shell, the pull toward shore. The pattern seems older than almost anything else swimming today. Ancient turtle ancestors swam seas that existed long before the continents took their current shape. Land masses drifted slowly apart while these early travelers kept moving through changing water. Whole oceans opened and closed around them across unimaginable stretches of time. Their descendants adapted, generation after generation, without losing the underlying urge to return to shore. That urge simply carried forward, quietly, through every shift in the map. Coastlines have shifted since then, yet the drive to return to land has persisted. Beaches vanished under rising water. New ones formed where none had been. Through it all, some deep instinct kept steering turtles toward soft sand and warm shallows. The specific shoreline changed many times, but the behavior itself held steady, passed quietly from one generation to the next. This behavior appears to predate humans by an enormous span of time. Long before any person stood on any beach, turtles were already crawling ashore to lay their eggs. Whole species of early humans came and went, while this same ritual continued undisturbed. Watching a turtle nest tonight means watching something far older than our own presence on Earth. The moment feels borrowed from a much deeper stretch of time. Somewhere far off, a low hum drifts through the dark, rising and fading like a tide that never quite reaches shore. Maybe it's wind moving through unseen branches. Maybe it's a house easing into the cool of night, settling boards and quiet pipes. It comes closer, then eases away again, asking nothing of you. Let your breath match its slow arrival and its slower retreat. There is only the sound and the dark holding it. A turtle swimming tonight follows a rhythm older than most of the world's mountains. Ranges we consider timeless rose from the earth long after this pattern first took shape. Wind, rain, and pressure carved and reshaped whole ranges, while turtles kept tracing their familiar loops through open water. Mountains rise and mountains erode. The turtle's rhythm simply continues beneath it all, unaffected by the slow architecture of stone above the waterline. Its route may cross paths with ships, but the instinct beneath it is far older than any vessel. Steel hulls and engine wakes are recent additions to waters turtles have crossed for ages uncounted. A modern container ship passing overhead means nothing to the compass working quietly inside the turtle below it. The instinct doesn't notice the difference between an ancient current and a modern shipping lane. It simply follows what it has always followed. Every stage of this journey, from nest to nest, forms a single unbroken circle. Egg becomes hatchling, hatchling becomes drifting juvenile, juvenile becomes adult, Adult becomes egg layer once more. No single stage stands alone. Each one depends on the one before it and prepares the one that follows. Seen from above, the whole life looks less like a line and more like a slow, patient ring drawn across an entire ocean. The lost years, the drifting years, the feeding years, all feed the same eventual return. Nothing in this long stretch of time is wasted or separate. Every mat of floating seaweed, every crab eaten near a quiet reef, every current ridden without effort builds toward one distant shoreline. The turtle carries all of it forward, unknowingly, until the pull toward home finally becomes strong enough to answer. A turtle's whole life reads like a very long, very slow sentence ending where it began. The first word is a nest in warm sand. The final word is another nest, in nearly the same place. Everything between, the ocean crossings, the years of drifting, the decades of feeding, forms the long middle of that sentence. And when the ending finally arrives, it closes gently, exactly where the story first opened. Distance, in this story, is not an obstacle but a kind of memory. What looks like thousands of kilometers of open water is, to the turtle carrying it, closer to a remembered path than a challenge to overcome. The body seems to hold the shape of the journey before it happens. Muscle, current, and inherited instinct move together as one motion. What we measure in numbers, the turtle simply lives. Ocean itself seems to remember these paths, generation after generation. Currents that carried one hatchling out to sea will carry another, decades later, in nearly the same arc. Coastlines shift only slightly across a turtle's lifetime, and the water above them keeps its old habits. Nothing writes the route down, and yet the pattern holds. Passed forward through water, salt, and instinct, rather than through any single mind. Somewhere tonight, a hatchling is crossing the sand toward the surf for its first time. Small legs push against grains, still warm from the day before. The horizon over open water pulls at something already awake inside it. It has never seen the sea, yet it moves as if returning to a place already known. In a few minutes, the water will close gently over its shell. Somewhere else tonight, a female is turning back toward deep water after laying her last clutch of the season. Her tracks lead down the beach behind her, already softening in the wind. She carries no memory of the eggs she leaves buried, only the pull of the current waiting beyond the shallows. The shore behind her grows smaller. Ahead lies the long stretch of open sea she has always known how to read. Both are part of the same long, continuing journey home. The hatchling entering the surf and the female returning to the depths stand at opposite ends of one unbroken circle, each carrying the other's future inside them. Every tide that has ever pulled a turtle out to sea has also, eventually, pulled one back. Your own rest tonight follows a rhythm just as old, just as reliable. Let your breathing slow, let your body settle, and let sleep carry you the way the current carries them, gently and without effort. Good night.